Hi, my name is Mel, and the following presentation will offer an in-depth exploration of mainframes covering their architecture, operation, software, environment, and capacity aspects. We'll examine key components and how mainframes support critical enterprise functions. We will begin by introducing mainframes, their history and characteristics. Then we will dive into their architecture, core operational principles. And the presentation also covers mainframe operating systems, software ecosystem, capacity considerations, storage, networking, security, and real-world applications. The following section provides foundational knowledge about mainframes, including their definition, historical evolution, and the major manufacturers driving the industry. Mainframes are powerful computers designed for large-scale computing tasks. Originating in the mid-20th century, they have evolved to support complex enterprise workloads reliably and efficiently. Mainframes are known for their high reliability, scalability, extensive input and output capacity, and ability to handle massive transactional volumes with strong security and availability. IBM remains a dominant mainframe manufacturer, with other companies contributing to their ecosystem. The competitive landscape influences innovation and service offerings. Understanding the architecture involves exploring CPUs, memory hierarchies, storage subsystems, and how input-output processors connect peripherals and external systems. Mainframe CPUs, or central processing units, are designed for parallelism and multitasking. The system structure emphasizes robustness, enabling simultaneous processing of diverse workloads. Mainframes employ layered memory systems, including cache, main memory, and high-capacity storage to optimize performance and reliability. Advanced input-output systems manage data flow between the CPU and peripheral devices efficiently, supporting high throughput and minimum latency. The following section explores the operational foundations such as batch and transaction processing, job scheduling, and the principles ensuring system reliability. Mainframes handle large batch jobs and real-time transaction processing, balancing throughput with responsiveness to meet enterprise demands. Sophisticated job schedulers allocate system resources dynamically, optimizing workload distribution and ensuring priority tasks are processed efficiently. RAS features, or reliability, availability, and serviceability features, enable mainframes deliver continuous uptime, fault tolerance, and easy maintenance to meet mission-critical requirements. You'd have redundancy too in there as well. Mainframe operating systems provide the platform for system management, virtualization, security, and application execution, supporting diverse enterprise needs. ZOS is the flagship of the IBM mainframe operating systems, with ZVM, which is Z virtualization machines, capacities, providing virtualization. Other operating systems options cater to various specialized workloads. Mainframe operating systems support extensive virtualization, enabling multiple logical partitions to maintain and maximize resource utilization and operational flexibility. Robust security models include access controls, auditing, and encryption to protect sensitive data and ensure compliance with regulation. In the following section, we explore the software tools and platforms for application development, database management, and middleware that enable mainframe functionality. Mainframe environments support languages like COBOL, PL/L, and modern tools enabling development of complex, reliable applications. So COBOL is a legacy one. It's an older language that probably uses more modern stuff as well. Mainframes commonly use high-performance DB or database management systems like DB2, optimized for transaction-heavy workloads with strong data integrity. Middleware facilitates communication between diverse applications and extensive systems, supporting seamless enterprise integration. The following section covers how mainframes measure performance and scale to handle massive workloads and resource allocation dynamically. Millions of instructions per second, MITs, and millions of service units, MSU, are key metrics to gauge mainframe processing capability. Okay? Mainframes are engineered to support thousands of simultaneous tasks and users without degradation in performance. Dynamic partitioning allows flexible allocation of CPU, memory, and input and output resources to meet changing workload demands efficiently. Storage solutions on mainframe combine speed, reliability, and data protection with advanced backup and disaster recovery systems. Mainframes employ both high-speed disk drives and tape storage for long-term data retention and archival purposes. Robust backup strategies and disaster recovery protocols safeguard business continuity in case of data loss or system failures. Caching mechanisms and fast storage tiers enhance data retrieval speeds, crucial for transaction-intensive applications. Okay, the following section talks about mainframe networking and connectivity. So networking enables mainframes to communicate with enterprise environments and with distributed and cloud systems seamlessly. While SNA was a traditional protocol, modern mainframes support TCP/IP to integrate with contemporary network infrastructures. So yeah, all modern mainframes would support TCP/IP because like SNA isn't really all that, and every network elsewhere uses TCP/IP. So yeah. And also too, like distributed means when you have like different computers here, there, and everywhere. I'm sort of like basically explaining it, but like a lot of times you would have distributed computing as well. Mainframes increasingly support hybrid environments, allowing integration with cloud platforms and distributed architectures. Mainframes remain central in data centers for mission-critical applications due to their performance, security, and reliability. The following section addresses how mainframes implement security controls and comply with industry regulations to protect data assets. And that's important these days because nothing is unhackable. Mainframes use strong encryption protocols to secure data in transit and at rest, maintaining confidentiality and integrity. So the basis of cybersecurity is CIA, confidentiality, integrity, and availability. So with this, you're getting all CIA because you're getting confidentiality and integrity, and it's highly available too, okay? That's in every system. You must have CIA, all right? Comprehensive logging and auditing capabilities help organisations demonstrate compliance with standards like PCI DSS and HIPAA, which are American regulations, but they would also support Australian as well. Advanced security tools detect intrusions and vulnerability, enabling swift countermeasures to protect mainframe environments. Mainframes power critical workloads across banking, government, healthcare, retail, and other large industries requiring robust computing. Mainframes process vast numbers of financial transactions daily, emphasizing security, speed, and availability. So, yeah. Governments and large enterprises rely on mainframes for managing complex data sets, social services, and administrative functions. In healthcare, mainframes manage patient data and billing, while retail sectors use them for inventory and transaction processing. Well, the bigger retail industries would. Smaller ones are just use, service databases and all that sort of stuff. So, in conclusion, mainframes do continue to be indispensable for enterprises requiring unmatched reliability, scalability, and security. Their evolving architecture and ecosystem ensure they remain relevant in modern IT landscapes. Thank you for your time.